Hello, welcome to Data Wrangling. For this section you will need some reference materials, and an excellent reference for you is R for Data Science, written by Wickham and Grolmont. It is a free online book that has different sections: exploration, wrangling or data transformation, programming with R, modeling with R, as well as a communication section. I highly recommend that as a quick reference for you whenever you would like to explore some specific R commands. Another great reference is the R tutorial by Kelly Black from the Department of Mathematics at the University of Georgia. It has very good introductory materials in intermediate plotting, indexing into vectors, linear least squares regressions, calculating confidence interval, p-values, two-way tables, etc. I highly recommend this tutorial whenever you want to do some specific statistical data analysis. One of the objectives of data wrangling is to have tidy data. A dataset is tidy when each column represents a variable and each row represents an observation. The next reference sheets that we are going to look at allow you to perform this easily and efficiently. RStudio has a set of reference tables. A special consideration has to be given to the following: tidyr, Dipler, Lubridate. Let's introduce RStudio. That is a very simple interface to use R. It consists of a menu, a console window where you can perform operations. In this case, we are setting x equal to 1, y equals to 2, and then perform the operation x plus y. That gives us 4. Notice how in the top right part you have an environment window where the values of these variables are set up. We also have in the upper left part a script window where you can record your operations and save them for later use. Here we are defining x equals 1, y equals 2, and x plus y. In order to perform each one of the lines, you position your cursor there, and the result appears in the console window, as you can see. Finally, we perform the operations x plus y, which in this case is equal to 3. If you want to perform all the lines at the same time, you select them and click Run. Let's save our script and name it. Click the Save icon, name it, let's call it My Script, and let's look for the folder where we are going to save it. I already created that folder. It's in Documents. R course data wrangling. Click Save. Now let's see that script file saved in the Files tab in the lower right part. There it is. Let's prepare. Now let's set that folder as the working directory, clicking in More and then Set Working Directory. You can see the command being performed in the console window. Now install a package. Let's install Tidyverse. Tools, install package. You just type the name of the package that you're going to use, in this case Tidyverse. And as you can see, the commands that you are performing appear in the console window. There it is. Once you install a package, you have to load it. So go to the tab Packages, locate that package, in this case is Tidyverse, and check the box. That is equivalent to the command that appears in the console window. Don't pay too much attention to the conflicts. That is normal according to the literature. Let's clean now our environment window by clicking the brush. That eliminates the variables. And if you press from your keyboard Ctrl L, I am going to write it there, Ctrl plus L, you will clean the console window. Now I'm going to delete Ctrl L. Let's do an exercise. For this, we are going to load a file called Palmer Penguins. That is part of a library that we can install and then load. And then we will save a file into Excel. After that, we will do some slicing and dicing. And finally, we will do some grouping and summarizing of this data. So, let's go on. Let's clean our data a little bit, and let's create a script called Palmer Penguins. We're going to save that in our working directory, and we're going to check it out. Go to the working directory. Yes, that's where we are. Now what we are going to do is we are going to install a library where those files related to some penguins are. So install packages, and the name of the package between quotes is Palmer Penguins. R is doing its work. And remember, after installing a package, in order to use it, we have to load it. And for that, we use the library command. Library Palmer Penguins. Notice the difference between Palmer Penguins with quotes and Palmer Penguins without quotes when we install the package and when we load the package. Now let's create a variable called penguins that is going to be equal to the file penguins that has already been uploaded. We'll run it, and there we have it. We have a file called penguins with 344 observations or rows and 8 variables. You can click on it in the environment window and you can see it. Notice how the console window has the view penguins command. There is an NA. NA means not available. That is the way in which R defines missing data. Now, let's save our data into Excel. It is also a good idea for good documentation to include comments in your script. A comment has to be preceded by the pound sign, so let's write the comment for the installation section and write another one for the loading of I'm sorry, for the saving of the data file into Excel. We're going to name this Excel file Penguinos. In order to save to Excel, we have to install another package. You guessed right. And this package is going to be called WriteXL. Remember, when you install a package, you have to type that between quotes. R is doing its thing. I think it is completely loaded now. I'm sorry, installed. In order to load it, we have to use the command library. Now it is. Now let's write the file as penguinos.xls in our working directory. For that we use the write xlsx command. And between parentheses, we first specify the name of the file that we want to save. In this case, this file or data frame is called penguins. And then, between quotes, we specify the name of the Excel file and its termination. And I made a small mistake here. It's not XLS, but XLSX. You can see that in the working directory, Penguinos XLSX. And now I'm going to use LibreOffice in order to view the file. I go to my taskbar, upload LibreOffice. I am using Linux. And then open Penguinos XLSX. And there it is. Mission accomplished. What we're going to do now is to install another package. The name of it is Harrell Miscellaneous. And the idea is to be able to know how many species we have, how many levels of the factor species we have. So we're installing Harrell Miscellaneous. After we finish the installation, I'm going to copy and paste the command that is in the console window into the script. Then we need to load the package, and for this I'm just going to the packages tab and check the box and copy paste the command from the console to the script for future runs. Now let's use the command describe from that library. In this case, we're going to describe the data frame penguins. The results are in the console window. I just scroll to the variable called species, or the column called species, and you notice that there are three distinct values of a species or levels of species: adeli, chinstrap, and as we specified before, we have three levels on the factor species or the variable species: adeli, chinstrap, and gento. So we will create three data frames that have only values for each one of the species. In order to do that, we will use the command filter, or the function filter. The syntax is very simple. Between parentheses, we enter the data frame that we want to filter, and then the condition that is going to filter the values from. In this case, species is identical in value as adeli. Notice the double equal sign. We run that, and in the top right window you can see that we have 152 observations of adeli in a different data frame. Let's repeat this for the remaining two species. One way in which you can know what is the size or the dimension of your data frame is by the command dim, dim. dim adeli in this case is going to give me the number of rows as well as the number of columns in each case. Now let's do chinstrap. The syntax is the same. Filter, enter the data frame we want to filter, and then the condition. In this case, species is identical to the value chinstrap. Between quotes. Finally, we will do gento. We can see each one of the data frames by using the command view or by just clicking on the environment window into each one of the data frames. Where can we find that function filter? in the dplyr cheat sheet that is being used to return a subset of rows from a table into a new table. Look at the logical or Boolean operations that you can use with filter. Let's now identify the data frames that have missing values and eliminate them. Now let's identify the data frames that have missing values and eliminate those missing values. For that we use the functions cbind, lapply, and is.na. cbind basically stands for column bind and is used to combine specified vectors or data frames. lapply returns a list of elements that are, in our case, is NA or missing, and this list is the same length as the column evaluated, which in this case is allele, the column allele, or the columns in allele, or the columns in Chinstrap, or the columns in Gentoo. As you can see, when you type in the script, you can also have a summary description of each one of the commands. You can see that allele has missing rows or columns in each case, and then it shows you the number of rows or cells that are missing. Chinstrap has no missing values. All of them are zeros. I mean, the sum of all the missing values is zeros. Let's see how Gentoo performs. Oh, there are missing values. Specifically in the column 6, you have pi. Well, now we know that 2 of the 3 data frames have NA or not available or missing values. So let's take them out of our data frames, and let's create new data frames without these missing values. Usually missing values need to be treated carefully. Sometimes a missing cell or value is being filled up by the average of all the other cells if they are numeric, or by some other criteria if they are non-numeric. This has to be done with utmost care, depending on the problem that you are dealing with. In our case, we are just going to omit them for sake of simplicity. For that, we use the function na.omit. Basically, what it's going to do is going to omit all the values that are missing from allele, and that is going to create a new data frame called allele full. As you see in the environment window, is being created. We create also Gentoo full, following the same idea. And now let's bind all these data frames, all these 3 data frames that have no missing values. And let's create a new data frame for that. we will call it new penguins, and that is going to be equal to bind by rows the 3 data frames that have no missing values. Gentoo full, Adelie full, and Chinstrap. And as my dear friends from La France say, voila, there you have it. Let me just expand the top window a little bit and scroll through it, so you will see that there are no missing values. Or you can just repeat the same command that we did before. In the reference sheet or table, you can see that the bind operator is very well described, and there is also a bind by columns in addition to the bind by rows that we have used. Now that we have done all the elimination of missing values, let's summarize and group them. To summarize data from a column, we use the function summarize. That's a dplyr function, as you can see. So we're going to summarize the data frame new penguins, and we are going to calculate the average. And the average is going to be the mean of the column bill length in millimeters. And that's it. Let's do something more complicated, or I will say sophisticated, right now. First, I'm going to type what we want to do, which is basically, let's calculate the average, minimum, maximum, standard deviation value of the bill length in millimeters. But let's do it by species, and let's order these values in descending order of the average. As you can see, we can perform a lot of operations there in sequence. But in order to do that in a much more simpler and elegant way, dplyr provides a very interesting operator called the pipe operator. Now, as you can see, I'm typing right now all this description of what I am going to do, or what we are doing, and I am omitting the pound sign. This is on purpose. You can see there is a red X around to the left of row 45 in the script window. We will correct this in a moment. let's just finish the description of what we are going to do. Now I select all those rows, go to code, and comment and uncomment lines. That is a way by which you can make a paragraph a set of comments. So we are going to create a new data frame called stats by species, and we are going to use new penguins as data frame in order to make all these calculations. Now I am typing the percent, greater than, and percent keys, and that represents the operator pipeline. Perhaps the best short definition of pipe in R is it's an operator that takes the output from one statement, usually the one on the left, and makes it the input for the next statement, the one in the right. This allows you to link a sequence of analysis or steps together. So look at the logic here. We are taking new penguins and then taking that and using it in order to group by species the data frame penguins. After that, we are summarizing by species the data frame new penguins and calculating the average, which is the mean of the bill length. Then calculate the minimum, again, of the bill length. Calculating the maximum. And calculating the standard deviation. The standard deviation is SD. The name that I am using for standard deviation is SDiv. And after that, I include another pipe operator once I finish with the operations preceding. Percent greater than percent, where I'm going to use the function arrange in descending order of the average. Then I will select all those lines and click run and see what happens. Oh, I have an error. It says unexpected special in the character pipeline. Usually that is because I just segmented all the big formula, so I'm just going to join it, as you can see, and run it again. There you go. That's it. So where can we see the pipe operator and an explanation of it? In the reference table. Over there we can see how to perform summaries, group bys, calculate means and standard deviations, as well as some other operations. Let's do one more exercise. This one is related to a time series. Let's start this new exercise. We're going to start with a clean RStudio environment, and we're going to create a script called coffee. Now, here I'm going to write what we're going to do. We're going to read a data file that is already in your environment folder. Your instructors might have given this to you as part of the set of materials. The name of this file is Global Price Coffee CSV. There are two ways to import this dataset. Just right click on it and then select import dataset. Immediately you will see a pop out window that tells you what is the code preview and how the data was pulled. Or you can go to the import file in the upper right corner and perform basically the same steps. In any well, let's continue. What we're going to do now is to create a data frame called coffee price. Both of them, coffee price and global price of coffee, are essentially the same, but we can work in coffee price without altering the original CSV data or CSV data frame that is global price of coffee. After that, let's change the names. First, we're going to obtain the names of the columns in our new data frame called coffee price. By that, we use the column names function. You can see that in the console window. Good. Then we will change the name of the columns. On purpose, I will misspell one of the names to do some editing later. Here I am saying that column names of coffee price are going to be the following values within a vector. See open parentheses and then enter the elements of each vector, which in this case are the names or titles of the two columns, in quotes. Here it is. You can see that we have changed the name of the columns. After that, we're going to create a data frame that has the columns for the month, the day, and the year that is described in the column date. To do that, we need to install a package, and the package is Lubridate, which is part of the Tidyverse universe. Now, notice the following. R is telling us that it needs to restart. After restarting the session, it installs the package, and of course we are going to load it with library Lubridate. Now we will create a data frame, coffee, that separates month, day, and year from the column date in the data frame coffee price. And we specify that in another vector where M is the month, D is the day, and Y is the year. Look what happens. And also note the order of the letters month, day, and year. They have to correspond to the way in which the numbers are ordered in the original column. We have an error, and we will discuss about that in a moment. The reason of our error is because when R restarted, all the libraries were unloaded. So now what we need to do is upload these libraries once again. So I'll just go to Packages, enter Tidyverse, and click Run in the previous operation, and there we have it. We have a new data frame called coffee price, and in order to view it, you can see that there are three columns: month, day, and year, and they correspond to the positions of the date column in the original coffee price data frame. Let's build back the date column. we are going to create another data frame called coffee bag. And we're going to use the pipe operator on coffee. To mutate, which is basically add a new variable. The date column into a date value by using the make date function from LibraDate, using the columns of year, month, and day. Notice how I am using year, month, and day, because that is the standard for time in a time series. Look at coffee bag and notice the difference. It has hyphens separating year, month, and date instead of slashes. In order to note the differences a little bit more, let's use the sapply function with a class operator. What it does is, for coffee bag, sapply with a class operator is going to tell me the type of variable that I have in each column. So for coffee bag, month is a character, day is a character, year is a character, US cents per pound is numeric, and the date column is a date value. Now let's apply for coffee price, the class operator in sapply, and as you can see, the US cents, the date in coffee price is just a character. Because this is originally a time series, I would like to be able to perform operations in a date value rather than a character value. That's the purpose of all this manipulation. Well, after you finish with the columns month, day, and year, we can just drop them. For that, what I'm going to do is I am going to select from the data frame coffee bag only the columns US cents per pound and the date. And of course I'm going to have an error because the name of US cents per pound is not pound, it's pond. But that is easily corrected. To US cents per pound. As in the original coffee bag. Now let's inspect coffee bag. You see that there are only two columns. The first one is US cents per pound, the second one is the date. Now it is standard formatting in a data frame that the first column is the date column. Usually that is used as an index of all the values that follow. So let's reorder these columns. So we create the vector column order or col underscore order with the vector date and US cents per pound. And then we're going to assign this vector or variable to coffee bag. And the format is very simple. Coffee bag again, open brackets, comma, enter col underscore order, and close the bracket. You can go to the internet and investigate why it is written this way. That's your first homework. Now let's see. Now let's correct that misspelling. US cents per pound instead of US cents per pound. As a summary from this section, we learn how to use mutate in the making of new variables. We also use some functions in LouvreDate. I strongly recommend you to look at this cheat sheet. But also you can see the function makeDate by using the Help tab and searching for it. There you go. And some tidier functions that we use is separate to split cells of a column. That's it. We have come to the end of this module, and the only thing to do right now is to exercise and to practice. So in your material you have some additional slides that provide the procedure to create some specific operations. For example, you can create two data frames and then bind them by row. Try to replicate this exercise in the slide as by yourselves or with a group. There is also binding frames by column. This is the command. These are the data frames. You should have this. One of the operations that we do a lot in R is joins, specifically the left join. When you create two data frames like A and B and they share one column in name, you can establish a left join, and the left join just matches the rows from B to A. Try to repeat it. There are some other types of join: inner joins, full joins, and right joins. Here is the way in which you will do a right join. In a right join, the matching is from rows from A to B. In the inner join, there is only the retention of rows in both sets, and in a full join, it retains all the values in the rows. Also, there are some operations called semi-join and anti-join, where all rows do not have a match, or all rows have to have a match. And finally, you can perform also set operations in R using the tidyverse set of packages, and one operation is intersect, which basically gets the rows that appear in both data frames. Union, that makes appear the rows that are in either of the data frames or both, and the difference, which is basically the rows that appear in one of the datasets but not in the other. And that's it. Those are the exercises for you. You can look at the references, you can look at the chat sheets. You can do it as a team. It has been a pleasure working with you. I wish you all the best in your endeavors, and I'll see you next time. Bye.